Let's wait for a couple of minutes. I will share the slides now. Is the slides visible? I hope it is fine. So, good evening, all. Welcome to week 7 tutorials of the course Pericyclic Reactions and Organic Photochemistry by Professor S. Raman from IIT Madras. Myself, Anisha Suresh, PMR of TA for this course from IIT Bombay. So, in week 7 modules, I have mainly discussed regarding the photochemistry of carbonyl compounds and some photochemistry of alkenes as well. And in the final lectures, I have discussed regarding the photochemistry of nitrogen compounds. So, we will be focusing on questions based on the contents of week 7 modules. Okay. So, coming to the first question. So, this is the question number 1. What is the mechanism of the following reaction? So, here the starting material and the product have been given and they are asking for the mechanism of the reaction. So, what is this reaction? So, as you can see, a nitroso compound is here. It is getting converted into an oxime. A sort of remote functionalization is taking place. So, this is the Barton reaction. So, how is the mechanism taking place? First, here there is a ONO that in the presence of photochemical condition, this ON bond will cleave, leading to formation of the radical. So we will draw the mechanism. As you can see here, from here under photochemical condition, if you are not able to follow, please feel free to stop. C8H17. Here there is a methyl group and here ONO. So that will undergo homolytic cleavage. This bond will homolytically cleave, giving O radical and NO radical. And here there is a methyl, here there is a hydrogen, hydrogen, two methyls, OAC. Now what will happen? So I will draw a little more clearly. O radical under H nu condition. Now this methyl group is in the this medial group is easily accessible to this O radical, and it is in alpha, beta, gamma, delta. Delta proton abstraction will be taking place, leading to formation of methyl radical. So how it is taking place? C8, H17. Here OH will be forming, and here new radical will be forming. Hydrogen, hydrogen. Here also beta hydrogen, OAC. Now this radical will recombine with the NO radical, leading to formation of C8H17, methyl, OH, hydrogen, hydrogen. Here O, sorry, CH2, it will be CH2 in double bond O. Okay. So this, if it will tautomerize, it will result in the formation of oxime. C8H17, OAC, double bond N OH. Oxime will be forming. Up to that, it is shown here in the product, and if this will undergo hydrolysis, it will lead to the formation of carbonyl compound, aldehyde. Okay. So first, what is happening under H nu condition? This ONO bond, this ON bond will undergo homolytic cleavage, leading to the formation of O radical and NO radical. Then this O radical will abstract the proton from this hydrogen, which is present at this position, alpha, beta, gamma, delta. Delta hydrogen abstraction will be taking place, leading to the formation of this radical, which will recombine with NO, leading to formation of this. It can undergo tautomerization, leading to the formation of oxime. This oxime, upon hydrolysis, it will lead to formation of aldehyde. Okay. So this is Barton reaction. Is the mechanism clear? Any doubts? If there are no doubts, we can proceed to question number 2. Before that, let me explain about Barton reaction. So Barton reaction, which is also known as Barton nitrate ester reaction, it is a photochemical reaction that convert an alkyl nitrate to a delta nitroso alcohol. Okay, so here this is a uh, alkyl nitrite. So upon photochemical irradiation, so this bond will homolytically cleave, leading to the formation of these two radicals. Okay, then a alpha, beta, gamma, delta. Delta proton abstraction will be taking place, leading to the formation of this radical, which will recombine with the NO radical, leading to formation of 2. Then this can undergo tautomerization, leading to formation of oxime. Fine. So this is one of important reaction of photochemical reaction of nitrogen containing compounds. Any doubts? So let us proceed to question number 2. Suggest the mechanism for the following reaction. So which reaction is this? It is a name reaction. So which is this reaction? Anyone? So this is Hoffman Loeffler Freytag reaction. Okay. So this can take place either under photochemical condition or under thermal condition. So what is the mechanism for this reaction? Please try to work it out. So here what is happening? Under H2SO4 acid condition, thus nitrogen will get protonated, leading to the formation of quaternary ammonium salt. Okay. So under H2SO4, this nitrogen will get protonated, leading to formation of this quaternary ammonium salt. Then what will happen? Under photochemical condition or under thermal condition, this bond will cleave. Okay, can be photochemical or thermal condition. This NBr bond will homolytically cleave, leading to formation of Br radical and this nitrogen cationic radical HCH3 plus radical. Now, this hydrogen is easily accessible for this nitrogen to abstract. So, it will abstract this hydrogen, leading to the formation of radical here. Here radical will be forming. Then this radical can recombine with the bromine radical. Both these radicals will be recombining, leading to formation of then any base can abstract the proton from the nitrogen, leading to neutralization of this positive charge. Okay, so minus H plus, it will lead to NHCH3. So the lone pairs on nitrogen will be free now. It can attack this in SN2 fashion, leading to bromine elimination. One, two, three, four. Hydrogen CH3 plus again minus H plus. It will give the desired compound. Okay, so this is Hoffman Loeffler Freytag reaction. Okay, HLF reaction. Is the mechanism clear? So first the acid will protonate this nitrogen. Then under photochemical condition or thermal condition, this NBr bond will homolytically cleave, leading to formation of this N plus radical and bromine radical. Then this N plus radical, it can abstract this hydrogen, which will be in alpha, beta, gamma, delta. Delta hydrogen abstraction will be taking place, leading to formation of this radical. This radical can combine with the Br radical. It will lead to formation of this intermediate. Then in the presence of some base, this positive charge on the nitrogen will be neutralized by abstraction of the proton. Then the lone pairs will be free. It can attack on this sender in SN2 fashion, leading to bromine elimination. Then it will result in the formation of this intermediate. This upon deprotonation, it will give the final compound. Okay.
Okay, ma'am.
So this is Loeffler Freytag reaction. It is a radical cyclization used to form pyrrolidine or piperidine rings from N-halogenated amines. Okay, it can be initiated thermally or photochemically. So this is the mechanism for the reaction. First, upon protonation, it will lead to chlorammonium ion, and then homolytic cleavage will take place, leading to formation of ammonium radical. Then this abstraction of will take place, leading to formation of the carbon radical. Then this carbon radical can recombine with the chlorine, leading to formation of this intermediate. Then in the presence of the base, proton abstraction can take place, leading to formation of this um, amine. Its lone pair will be free. It can attack at the sender, leading to chlorine elimination. It will result in the formation of this intermediate, which upon deprotonation will give the skeleton. Okay, so pyrrolidine or piperidine rings can be formed from N-halogenated amines using this Hoffman-Loeffler Freytag reaction. Clear? Now coming to question number 3. So the major product M in the following reaction is. So this is the starting material. In the presence of H nu, that is under photochemical condition, it is giving a product M. And this AR, it is the phenyl ring substituted with CN at the fourth position. Okay. So what will be the product that is forming? 4 options have been given. Please try to work it out and try to find the right answer. So what sort of reaction is this? This is an example of di-py-methane rearrangement. Okay. So what, which is the major product that is forming after this reaction taking place? Anyone? Four options have been given. Out of that, which is the major product that is forming after di-py-methane rearrangement taking place? So let us see the mechanism first. As you can see here, under photochemical excitation, this tetra radical will be forming. Then these two radicals will recombine, leading to formation of this cyclopropane. Then this cyclopropane will undergo bond cleavage, okay, leading to formation of this tertiary radical. Then which bond will recombine to give double bond, and which bond will recombine with the radical? This radical will depend upon the stability of the radical. So in this case, this AR group, it is right. This is the AR group. So that group will stabilize the radical because of the presence of this CN at the fourth position. So because of that, this recombination leading to formation of the double bond will be taking place first, and then these tertiary radical will recombine with this radical, leading to formation of the cyclopropane. So option 1 will be the major product that is formed in this reaction. Okay. So this is a di-py-methane rearrangement. Under photochemical condition, this alkenes will undergo irradiation, leading to formation of this tetra radical. Then a bond formation will be taking place between these two radicals, leading to formation of the cyclopropane. Then what will happen? This radical recombination will take place, like this bond will cleave, leading to formation of this tertiary radical, and these two radicals, this radical and this radical, will recombine, leading to formation of double bond PH. Okay. Then after that, this tertiary radical can recombine with this radical, leading to formation of the final product. So because of the stability of the radical that is formed here, it is recombining with this uh, tertiary radical in the final step. First, this bond formation will be taking place, followed by the formation of the cyclopropane ring. Okay, is it clear? So if there are no further doubts, we can move to question number 4. Write the mechanism of the following reaction. So which sort of rearrangement reaction is taking place here? So as you can see, this is a di-pi system. So it will undergo a di-pi-methane rearrangement. Okay. So the mechanism is given in detail here. So first, under photochemical irradiation, this tetraradical will be forming. Then this, if you are numbering, 1, 2, 3, 4, 5, 6. Then formation of a new bond will be taking place between the carbon 2 and carbon 4, leading to formation of the cyclopropane. Then next what will be happening? The bond will be breaking between carbon 3 and carbon 4, leading to formation of the tertiary radical, and a new bond will be forming between the carbon 5 and carbon 4. Okay, like this. First, this recombination is taking place, leading to formation of this intermediate. Then this radical will be forming, tertiary radical will be forming, and this new bond will be formed between carbon 5 and carbon 4, leading to formation of this intermediate. Now these two radicals will combine. There will be a new bond formation between carbon 1 and carbon 3, leading to the formation of the final product. Is the mechanism clear? First, upon irradiation, this tetra radical will be forming. Then bond formation will be taking place between carbon 2 and carbon 4, leading to formation of this intermediate. Then a, a new bond will be formed between carbon 4 and carbon 5 by this mechanism, this arrow pushing mechanism. This bond will be breaking, leading to formation of a radical at C4. Then C4 C5 will recombine, leading to formation of double bond here, and a new radical at C3 position. That C3 radical and C1 radical will recombine, leading to formation of the final product. Is the mechanism clear? So this di-pi-methane rearrangement, Barton reaction, Hoffman-Loeffler-Freytag reaction, these all are important reaction. Maybe in exams also you can get questions regarding that. Sir have mentioned in the lecture that Barton reaction is his favorite reaction. So maybe there is chance that in exams he can ask question from Barton reaction. Okay. Now coming to question number 5. Reactions of ketones and alkenes in the presence of light to form oxytanes is known as. Okay, ketones and alkenes in the presence of light, they will react to form oxytanes. So that reaction is known as option A, 1 Norrish type 1 reaction, option 2 Paterno-Bucchi reaction, option 3 Diels-Alder reaction, option 4 Norrish type 2 reaction. Which one? It is Paterno-Bucchi reaction. Okay. So how Paterno-Bucchi reaction is taking place? So Paterno-Bucchi reaction, it is a photochemical reaction, specifically a 2 plus 2 photocycloaddition, which forms four-membered oxytane rings from an excited carbonyl that is reacting with an alkene. Okay. So this is how the reaction will be taking place. Under photochemical irradiation, the carbonyl will irradiate and will undergo excitation leading to the formation of this oxygen radical and carbon radical. Then it can attack on this alkene in this fashion, leading to formation of this radicals. This upon recombining, it will give the oxytane. Fine. So here there are two chances. This is an unsymmetrical alkene. So the reaction can also take place in this fashion, like double bond leading to formation of pH O dot H, and then recombination leading to formation of pH. But here you can see this is a secondary radical, whereas in this case it is a tertiary radical. So tertiary radical is more stable compared to that of the secondary radical. So this will be the major product that is formed. So as you can see here, there are two possibilities. It will give 2A and 2B. So out of which this will be the major product and this will be the minor product depending upon the radical stability. Okay. So the right answer were the alkenes and carbonyl compounds react to form oxytane rings. It is Paterno-Bucchi reaction. Fine. Now coming to question number 6. The major product formed in the following reaction is. So here also we are having a carbonyl compound, and under photochemical reaction it will undergo some sort of reaction giving a product. So out of this 4, which is the right answer? So I will give a clue. So this compound will be undergoing Norrish 2 type reaction. So what will be the final product? So here what will happen under photochemical condition? This ketone will irradiate leading to formation of this radicals. Okay. Then it can undergo Norrish 2 type reaction, that is gamma hydrogen abstraction, alpha, beta, gamma. Gamma hydrogen abstraction will be taking place leading to formation of OH and this carbon radical OH dot 1, 2, 3. So here the radical will be forming. Okay. So these two can recombine leading to formation of a cyclobutane ring. So option 4 will be the right answer. Okay, so this is undergoing a Norrish 2 type of reaction. So Norrish 1, Norrish 2 type reactions, these are important for photochemical reaction of carbonyl compounds. So this is how it is taking place. In this reaction, photolysis of the CO bond occurs, followed by removal of the gamma hydrogen and then cyclization. So first photolysis of this CO bond, that is irradiation leading to formation of O radical and carbon radical will take place leading to formation of this. Then this gamma hydrogen abstraction will be taking place leading to formation of carbon radical. That carbon radical will recombine with this carbon radical, leading to formation of this product. Okay, this oxygen will be abstracting this gamma hydrogen. Oxygen radical will be abstracting the gamma hydrogen. So the right option is option number 4, that is the 6-membered ring fused with a 4-membered ring. Is this clear? Now moving to question number 7. The major product formed in the following reaction is. So here, this is the compound. It is treated with NOCl in the first condition, followed by photochemical reaction and then treatment with HCl. So which reaction is taking place in these conditions? We have already discussed in today's tutorial regarding this reaction. So which reaction is taking place here? So in the first condition, OH upon reacting with NOCl, it will form ONO, right? So by seeing this, which will be the reaction that is taking place here? So these conditions correspond to that of Barton reaction. Okay. So how it is taking place? We will explain with mechanism. We are having OH. So this is the starting material. Upon treating with NOCl, it will lead to formation of O, NO. Okay. Then under photochemical condition, this ON bond will cleave, leading to formation of O radical and NO radical. O dot, NO dot. Okay. Then this O radical will abstract the alpha, beta, gamma, delta hydrogen, leading to formation of this carbon radical. Okay. This carbon radical will be forming, and here OH will be forming. Then this carbon radical and NO radical will recombine, leading to formation of ONO and OH. This ONO, it can undergo tautomerization leading to formation of OH, O, sorry, not ONO, that is mistake. It is CH2 N double bond O. Okay. So it can tautomerize leading to formation of this oxime. Fine. Then what will happen? In the HCl condition, this will undergo hydrolysis leading to formation of aldehyde. Fine. Is the mechanism clear? So option 1 will be the right answer. Any doubts? First, under NOCl condition, this OH will react with NOCl leading to formation of ONO. Under photochemical condition, this ON bond will homolytically cleave leading to formation of O radical and NO radical. Then this O radical will abstract the gamma hydrogen that is in proximity to leading to formation of OH and this carbon radical. Then that carbon radical can recombine with the NO radical leading to formation of this, and it can undergo tautomerization leading to formation of the oxime. That upon hydrolysis it will lead to formation of the aldehyde. Is the mechanism clear? Hello.
Good evening, ma'am.
Good evening.
Ma'am, this is Jyoti.
Okay.
I have a small doubt regarding the mechanism.
Okay.
Actually, you told that it is reacting with gamma hydrogen, right? Where it is cleaving
No, delta hydrogen.
delta hydrogen. Okay. Why can't it react with another side?
Another site means
This OH bond is there. Here also one CH methyl group is there, right?
this one.
In the first structure. In the first structure. If you
Okay.
see the first structure,
Yeah.
so NO is attacking here, right? On in place of H plus.
Here NO is reacting and leading to formation of ONO.
Okay. After that, in presence of H mu under the sunlight,
Hmm.
this radical will be reacting.
Yeah.
So this methyl group, wherever the bond, hydrogen bond is cleaved.
This one.
Okay.
Yeah.
This one.
Hmm.
Why can't the reaction will be taking place down or other methyl groups? We can see here two lines.
Actually, this is axial, na. So
Ah,
this will be in proximity. Equatorial will be away in space.
okay, okay. So whichever the molecules are nearby, it will be reacting
Yeah.
faster.
Yeah.
Okay, okay. What is the name of this mechanism, ma'am?
Barton reaction.
Okay, okay. Okay, okay, ma'am.
Hmm.
Okay, okay. Thank you.
Clear, right?
Cleared, ma'am. Okay.
Okay. Now coming to question number 8. Complete the following Norrish type 1 reaction. So we are having a carbonyl compound here. It is undergoing Norrish type 1 reaction. So in Norrish type 1 reaction, what is the first step? So in Norrish type 1, first alpha fragmentation will be taking place. So let us see the mechanism of how this reaction is proceeding. So first, this is an saturated acyclic ketone. So it will undergo a Norrish type 1 process in gases as well as in solution phase. So first, what is the primary process that is taking place? Here, this is our starting material. Under photochemical irradiation, it will undergo alpha fragmentation. That is, alpha carbon bond will be cleaving, leading to formation of this two radicals. Okay. Now, what will undergo? This is the primary process that is taking place. That is alpha fragmentation. Now, what it can undergo? First, a decarbonylation can take place, like in this fashion, leading to formation of CO and this radical. Then this radical can recombine with this radical, leading to the formation of the final product. Okay, or either it can undergo self condensation or self recombination also. It will give the same final product. So this is almost 100% yield. So this is how the Norrish type 1 reaction is taking place in the substrate. Is it clear? First, it will undergo a alpha fragmentation reaction leading to formation of this carbon radical and this radical. Then in the secondary process, a decarbonylation will be taking place leading to formation of this radical and the carbon monoxide. Then these two radicals can undergo recombination leading to formation of this as a final product. Okay, even if it is undergoing self recombination, it will give the same final product. Now coming to question number 9. Identify A and B in the following reaction. So this is a carbonyl compound. So which sort of reaction it will be undergoing? So this is the beta bond and this is the alpha bond. CH3 is alpha, phenyl is beta. Okay. So here also a Norrish type 1 sort of reaction is taking place. So first alpha fragmentation will be taking place leading to the formation of the CO radical and this radical. Now what will be happening? as you can see here. Now a this bond can undergo photolysis, leading to formation of a carbene sort of intermediate. So here O dot and here double dot will be forming. Then that O dot can recombine with this, leading to formation of this compound. Actually, they have drawn it a little rotated, okay? Like this, if cleaving is taking place in this direction and it is recombining, that product they have given here. Now, here this is an electron deficient sender, so the methanol can attack here either from alpha phase or beta phase. Okay, depending upon that, we will be getting two products. Since these chiral centers are fixed, depending upon the attack of the methanol, either from the alpha phase or beta phase, we will be getting two products. Okay. If it is attacking from the alpha phase, we will be getting B, and if it is attacking from the beta phase, we will be getting A as the major product. So in the question was what is A and B. So this is the final answer. So first here a Norrish type 1 sort of reaction is taking place. That is alpha fragmentation. Then this sort of homolytic cleavage will be taking place, leading to formation of a carbene sort of radical here and an O radical, and that will recombine with this tertiary radical, leading to formation of this. And then the sender is electron deficient, methanol can attack it from either beta phase or alpha phase, leading to formation of two products A and B. Okay. Any doubts? Is the mechanism clear? Okay. Now coming to question number 10. Give the mechanism of the given reaction. So this is a dienone sort of system. Okay. So this is rearrangement reactions in dienones. So how it is taking place? Please try to work it out. Take a moment. So first, under photochemical irradiation, this carbonyl will get excited, leading to formation of O radical and this carbon radical. Okay. So I will draw the mechanism under H nu. This will pH, OH, O dot dot. Then what will happen? This bond can shift here, leading to formation of an enol radical. O dot, and here a radical will be forming pH OH. Okay, then these radical can combine with this alkene, leading to formation of a cyclopropyne intermediate, pH OH, and here the radical will be forming O dot. Then it will form a sweeter ionic intermediate upon like this is N to pi star excitation. Na? So once it is coming from pi star to N, that is D motion, it will lead to formation of sweeter ionic intermediate O minus and here A plus, pH OH. So this upon coming, this bond will cleave and it will attack at the center, leading to formation of double bond O and pH OH. Okay, now after getting this, it again can undergo excitation, leading to formation of O dot, pH OH. Now here like this, the dienol can form, the enol radical can form, pH OH dot O dot. Then upon pi star to N demotion, it will lead to formation of sweeter ionic intermediate OH pH plus. Now this will lead to formation of ketone here and proton transfer to this alcohol O minus. It will lead to formation of the final product OH. Just I will redraw. OH double bond O pH, which is this final product. Okay, this is the reaction of dienones under photochemical condition. So first, upon excitation, this carbon radical, uh, this O radical and carbon radical will be forming. Then it will react with this alkene, leading to formation of this enol radical. Then this radical will react with this alkene, leading to formation of the cyclopropane intermediate. Then here a demotion, pi star to N demotion can take place, leading to formation of the sweeter ionic intermediate. So this O minus upon falling here, this double bond will shift and this bond will break and it will attack at this positive center, leading to formation of this intermediate. Okay, then again under photochemical condition, this carbonyl can excite, leading to formation of this O radical and carbon radical. Then this cyclopropane bond can cleave, leading to formation of this enol radical and this tertiary radical. Okay, then upon demotion it will form a switterionic intermediate. So these two are switterionic intermediates. Switterionic intermediate. This is also a switterionic intermediate. Now this oxygen lone pairs upon falling, it can neutralize this positive charge leading to formation of the ketone. Then this H plus can undergo proton transfer to this O minus leading to formation of the final product. Is the mechanism clear? Any doubts? Is it clear? There are no doubts. We can move to question number 11. So this is question number 11. Match the following starting compounds with corresponding products in photochemical reaction. So these are the starting materials, and among this, the products of these starting materials upon photochemical reaction is given. So match the following. So this, how it is undergoing photochemical reaction. Double bond O under photochemical condition. It will be undergoing which reaction? It will be undergoing a Norrish type 2 reaction. So what will happen? O dot, this will be forming, and alpha beta gamma delta, alpha beta gamma, sorry, alpha beta gamma, this proton will be abstracted, right? See, it will excite O dot, carbon dot, then alpha beta gamma, 1, 2, 3, 4. Gamma proton will be abstracted by the oxygen, leading to formation of O dot, OH, carbon dot, alpha, beta, gamma. Here the radical will be there. Then these two radicals can recombine, leading to formation of OH. This is also CH2, okay? And nearby that another CH2 will also be there after recombination. Okay? This is undergoing a Norrish type 2 reaction. And in the second case, we are having a cyclohexanone substituted with methyl at this position. So it will be undergoing a Norrish type 1 reaction. It is undergoing an alpha fragmentation, leading to formation of this carbon radical and this radical. Then alpha, beta, gamma, delta. Delta hydrogen abstraction will be taking place, leading to formation of aldehyde, double bond OH. So here also radical, here also radical. This can recombine, leading to formation of 3 double bond. So this is the final product that will be forming. Okay. So this one, it will give E, 2, it will give A. And this 3, it can undergo cis trans isomerization, leading to formation of B. So the right option will be 1 is E, 2 is A, and 3 is B. Okay, option 1 will be the right answer. Is it okay? In first case, a Norrish type 2 reaction is taking place. In second case, a Norrish type 1 reaction is taking place. And in third case, a cis trans isomerization of alkene is taking place, giving the final products. Okay, so here this is a CH2. Okay, this is a CH2. So option 1 is the right answer in this question. It is clear, na? Now let us move to question number 12. On irradiation using UV light, which is greater than 300 nanometers, compounds X and Y predominantly undergo. So here two compounds have been given. Okay, two compounds have been given. So one can undergo a Norrish type 1 reaction and the other can undergo a Norrish type 2 reaction. Okay, for Norrish type 2 reaction to take place, so there should be feasibility for gamma hydrogen abstraction. So in which case there is possibility for gamma hydrogen abstraction, depending upon that one of these compound will be undergoing Norrish type 2 and the other one will be undergoing Norrish type 1, which is alpha fragmentation, and then subsequent secondary reactions. So which of these compounds X and Y will be undergoing a Norrish type 2 reaction? So let us see. So for Norrish type 2 reactions, it can occur only when this hydrogen is within a specific distance to that of the carbonyl. So this you don't have to remember, but hydrogen should be proximal to that of the carbonyl so that the Norrish type 2 reaction will be taking place. If in compound X, the Y atom, like here the Y hydrogen atom, the hydrogen atom that is present at the Y position is accessible as it is close to that of the carbonyl, making the Norrish 2 reaction achievable. However, for molecule Y, in the case of Y, the hydrogen atom that is present in the Y carbon is unreachable by the carbonyl group, sorry, carbonyl oxygen, rendering Norrish type 2 reaction infeasible. So the Y hydrogen is readily available in molecule X. So in this case only, the hydrogen is accessible to that of the carbonyl for abstraction. So the gamma hydrogen abstraction will be taking place in compound X alone compared to that of Y, where this gamma hydrogen is distant from that of the carbonyl group. Okay, so in this case, O dot, carbon dot will be forming after irradiation. So here this O dot can abstract this gamma hydrogen, alpha, beta, gamma. Alpha, beta, gamma. So this can abstract this hydrogen, leading to formation of OH. Here a radical will be there, and these two radicals can recombine. One, two, three, 4. A 4-membered ring will be forming. So this will be the final product that is forming in this reaction. So this compound X will be undergoing a Norrish type 2 reaction, and in this case compound Y, because this hydrogen is far away from that of the carbonyl or from the accessibility of the carbonyl, so it will not undergo a Norrish type 2 reaction, so it will be undergoing a classical Norrish type 1 reaction. Okay, so this will undergo Norrish type 1 reaction. So out of this is undergoing a Norrish type 2 because of the proximity of this gamma hydrogen, and this will undergo a Norrish type 1 reaction. So option 2 will be the right answer. Is it clear? Any doubts? So option 2 is the right answer. Now coming to question number 13. Complete the following reaction. So seeing the starting material, what is the reaction that is taking place here? So it will be undergoing a di-π-methane rearrangement. Okay, so how it is taking place? What will be the final product? Let us see the mechanism. So here, upon irradiation, these radicals will be forming, or we can tell like it will lead to formation of the tetra radical like this, pH. Okay, then these two radicals will recombine, leading to formation of pH, is cyclopropane. Okay, out of which this radical is stable and this radical is less stable, so this will be recombining, leading to bond cleavage at this position, and a new radical will be generated here. Okay, so two out of these two radicals, this is less stable, so this is stabilized by reaction with this bond. This will lead to bond cleavage, leading to formation of pH radical and this intermediate. Then this two radicals can recombine, leading to formation of the cyclopropane ring. Is this clear? So this is an example of di-π-methane rearrangement. First, upon irradiation, it can lead to formation of either these diradical, or it can lead to formation of the tetraradical. Then these two radicals can recombine, leading to formation of the cyclopropane ring. So out of these two radicals, this is less stable radical, so this will be reacting faster. So it will lead to form. It will, when it is trying to recombine, this bond will be breaking, and a radical will be generated at this position and this position. So this radical will recombine with this radical, leading to formation of double bond here. So this is a tertiary radical. That tertiary radical will react with this more stable phenyl radical, leading to formation of the cyclopropane ring. Clear? Now coming to question number 14. Complete the following. So this is the starting material under photochemical condition. What is taking place here? So this is also an example of di-π-methane rearrangement. So how it is taking place? Let us see. So upon irradiation, see, these two radicals will be forming, or either we can say like this. pH, these two radicals and these two radicals can form. So here there is a possibility for getting a more stable radical by shifting to this position, right? So what will happen? This bond will shift in homolytic fashion, or this bond will recombine with this radical, leading to formation of a new radical center here. So this will, so a ring expansion will be taking place. As you can see here, first it was a 6-membered ring. This bond is shifting to this position, leading to formation of a radical at the center, which is a tertiary radical, that is more stable radical. So this ring expansion is taking place, leading to formation of a 7-membered ring. Now what will happen? These two radicals will recombine, leading to formation of the cyclopropane. Clear why this 1,2 shift is taking place? So this is a secondary radical. After shifting, the radical that is formed here, this is a tertiary radical. So because of that, this 1,2 shift is taking place, or we can tell this position 1 has an allyl group that is present. So because of that, this radical at this position will be more stable. So this 1,2 shift is taking place. After that recombination of these two radicals, it will lead to formation of the cyclopropene, giving this final product. Clear why this reaction is taking place or how this reaction is taking place? Now coming to question number 15. Write down the mechanism of the following chemical reaction. So this is the starting material and they have given that under Reschneu condition it is undergoing a Norrish type 1 reaction giving this product. So what is the mechanism of this reaction? So it will be undergoing alpha fragmentation. So it will undergo alpha fragmentation at this position, as here it will be giving a secondary radical. If it will undergo here, it will be giving primary radical. So that will not be stable. So it will undergo alpha fragmentation at this position, leading to formation of double bond O radical, and here this radical. Okay. Then alpha, beta, gamma, delta hydrogen abstraction will be taking place. Delta hydrogen abstraction leading to formation of just 1 second, I will redraw. Double bond O, these two radicals. Then these two, here hydrogen will be coming and aldehyde will be forming. These two radicals can recombine, leading to formation of double bond OH. Okay. So this is 1, 2, 3, 4, 5. 5-membered ring with an alkene. And if you number 1, 2, 3, 4, 5, 1, 2, 3, 4, 5, at the fifth position, a carbonyl group is coming. Okay, so this is how you are getting this final product. Clear? How Norrish type 2 type 1 reaction is taking place? Alpha fragmentation is taking place first. So there are two possibilities for alpha fragmentation. Either it can take place from this side, or 1 second, from this side, right? But this is not feasible because it will lead to formation of the primary radical here. So this alpha fragmentation is favored. Clear? So first alpha cleavage is taking place leading to formation of these radicals. Then a gamma hydrogen abstraction will be taking place leading to formation of this alkene and this aldehyde. So this, if you redraw, it will give the final product. Is the mechanism clear? Any doubts? If it is okay, we will see question number 16. So this is a match the following. I think this is an easy question. So four reactions have been given and its representation is also given. So just you have to match the following. Norrish type 1 reaction. Out of this 1, 2, 3 and 4, which is Norrish type 1 reaction? Hmm? Anyone? So in Norrish type 1, alpha fragmentation is the primary step, right? So out of this 1, 2 and 3 and 4, where alpha fragmentation is taking place? So here you can see this is undergoing an alpha fragmentation, right? This is undergoing an alpha fragmentation and hence this can be matched with that of 1. So 1 will be coming 3. Now Norrish type 2. In Norrish type 2, the key factor is gamma hydrogen abstraction. So out of the other 3, which is having a gamma hydrogen abstraction? As you can see in option 1, here a gamma hydrogen abstraction is taking place leading to formation of this product. Okay, so here the gamma hydrogen abstraction is taking place. So 2 can be matched with this 1. Now oxetane formation. Oxetane formation we have. So oxetane formation we have seen in Patano-Bucchi reaction, that is a carbonyl compound and an alkene will lead to formation of oxetane. Okay, so this is Patano-Bucchi reaction where an oxetane formation is taking place. So this 3 can be matched with that of 2. Okay, and photo reduction where this carbonyl is reduced in the presence of photochemical condition leading to formation of the alcohol. So 4 can be matched with 4 here. So this is the match the following for this reaction. So this 3 is an example of Norrish type 1 reaction. This 1 is an example of Norrish type 2 reaction. And this 2, it is an example of oxetane formation, which is the Patano-Bucchi reaction. And this 4 is an example of photo reduction reaction. Okay, this Norrish, Norrish, photo reduction. Okay. Is there any doubts in any of the questions we discussed today? Hello? Any doubts in any of the questions we discussed today? If there are no further doubts, we can conclude today's session. So today we have discussed mainly questions based on the photochemistry of carbonyl compounds, which is mainly the Norrish type 1 type 2 reactions, and then Patano-Bucchi reaction, and some photochemistry of nitro compounds, nitrogen containing compounds like Barton reaction, this HLF reaction, etc. So next we will be having lecture on 15th and 16th, where 15th will be a summary lecture and 16th will be the last tutorial, that is tutorial number 8. Okay, if there are no doubts, we can wind up today's session. Thank you. Thank you.